Hi everyone, and welcome back to Math 11. So in this video we are going to be looking at section 3.3 which starts with the cosine law. Now in this case I'm not going to go over the proof for the cosine law. Basically it uses Pythagoras and some trigonometry to come up with these three relationships. But if you are interested in looking at the full proof, you can read it in the textbook, pages 130, 131. If this was pre-calc 11, I would definitely want you to know how to prove this yourself. But in our case, in this course, we just want to be able to know how to properly use this and when to use this cosine law. So again, we're dealing with acute triangles where we have angles which are not 90-degree angles. So we don't have a right triangle. We could split it into a right triangle and probably solve it using trigonometry like you've done in grade 10. But again, that's where we come up with this relationship, so we wouldn't have to do those steps. So again, rather than go through the proof, we're just going to start with the actual law. So sine law had two forms. Either you have the sine at the top and the length on the bottom, or you have the length on the bottom, on the top, sorry, and the sine on the bottom. Now in this case, for the cosine law, there's three forms. So if you look here, the lowercase letters again are side lengths, and the uppercase letters are the angles. So if you're looking for side A squared equals to B squared plus C squared minus, and then all of this stuff, 2 times B, C times cos A. And then if you look here, the pattern kind of repeats, but the only difference here is that if you're looking for side B, you're going to end up with A squared plus C squared, the other two letters, and then the cosine B appears, the angle B appears in the cosine there. So that's one way you can remember these, is that basically if you look for side A, you're going to end up with the cosine A in the expression, and then you have the B squared plus C squared, so the other two letters squared, and then minus 2, again, B and C, 2 times B and C. Here we have A squared plus C squared, and then we have minus 2, 8 times C. So again, the only times the letter B appears is going to be in the cosine for the angle B. So same thing for side C. So I recommend that whenever you do your homework, just write out the cosine law so you have it in front of you, so you can always look at it. So it really matters how you label your triangle. So for example, if you use some other letters other than A, B, C, of course these expressions are going to change. From A, B, and C, you might have, I don't know, X, Y, Z, right? So pay attention what letter is what when you're trying to, for example, deal with different letters. So let's see how we can use this and why we actually bother using the cosine law. So let's say we have this example 1. The question says determine the missing side of the triangle. So if you look here, we're given two sides, given this side here and that side there. And we have to find the missing side. So in this case, let's take a couple moments here and actually finish labeling it. So if this is angle A, right opposite to it is going to be the side A. And if this is angle C, this is going to be our lowercase c. If this is angle B, this is going to be our lowercase b. So now we have all the sides labeled. So in this case, we're missing this side A. Whenever possible, you want to use the sine law. But for the sine law, we need to have an opposite side to the angle, or we need to have at least two angles and one side. In this case, we have two sides, but none of these sides are opposite to the angle that's given. So we don't know A. And again, we don't know any other angles. So there's no way we can use sine law in this case. That's why you have cosine law, which allows you to find missing side, or let's say missing angle, if you have two sides and just one angle given. So we are missing side A. Now in this case, because I'm using the same letters A, B, and C, I don't really need to think about the expression, how to change it to whatever letters the question might have. So all I have to do really is just pick the right side in the formula that's already given. I'm going to rewrite it one more time so I have it in front of me. So it's going to be the A squared plus, equal to B squared plus C squared minus square bracket 2 times B times C times cosine of angle A. So that's the formula that I need to use to find side A. Now notice this is A squared, this is not A. So for the A itself, if I were to write the expression for A, I'll have to take the square root on the right side. So I'm going to have to square all this, screw this whole thing. So this is actual expression for the side A. So remember, this is this relationship is derived using Pythagoras and trigonometry. So again, you can look through the full proof to see how they came up with it. So this would be the actual side A if you're just looking for the side A. So 2bc times cos of A. So in this case, because the letters match and we relabeled the sides, the only thing we have to do is now plug in the numbers into the formula and get the right answer. Make sure, again, the calculator is set to degrees, not to radians or gradient. So let's see, A is going to equal square root of b squared. B is 32, so I'm going to write 32 squared. Again, in this case, the most common mistakes with cosine law is people forgetting to square or taking the square root as a final step. C is 40, so it's 40 squared, minus 2 times b, which in this case is 32, times c, which is 40, times the cosine of angle A, which is 58 degrees. So all of this is going to get square rooted. Next, you're going to take your calculator. You're going to do all this on the calculator. So you're going to do 32 squared. Make sure you know how to use the square button on the calculator. So you have 32 squared plus 40 squared. You get 2,622. Now, normally I wouldn't split this, but just for the first example, I'll show you what I've done so far. So this, just these two numbers, 32 squared plus 40 squared, give you 2,624. Okay, then I'm going to do 2 times 32 times 40 times the cosine of 58 degrees. And this gives me 1,356.593316. So I'm going to keep a bunch of decimals. So normally you wouldn't do this step, you would do this on the calculator. Right, so as you can see here, that this number is bigger than that number. Okay, so we will end up with a positive number inside of the square root. If you end up with a negative inside of your square root, that means that there's no solution, so this is not a triangle, or perhaps you made a mistake somewhere. So this is a good place to check whether you're getting a positive or negative number inside your square root, because remember, you can't take, so make sure you make a note here, can't take a square root of a negative number. Okay, so just as a precaution, good way to check whether you're doing your work right or wrong. So in this case, I know I'm going to end up with the positive because this number is bigger than that one, so I will end up with a positive. So let me see, 2624 minus the answer, I get the following. So A is going to equal the square root of 1,267.406664. So anyway, like I said, normally you would not have to write these steps. This is just to show you that we do end up with a positive here, so then I can take the square root of this number. Okay, so take the square root as a final step. So take the square root of this 1,267.4, and the answer, in this case, we're not asked to round to any particular number of decimals, so you're just going to try to match the number of decimals on the other side. So in this case, we're going to round to the nearest meter. So I'm going to write 35.6, looks like a bunch of zeros here, so meters, or if you were to round to the nearest meter, your A value is going to be 36 meters, right? You have to round it up. So there you go. This is a case where you could not have used sine law directly, right? And actually, you can't really do much here with trigonometry either, because I mean, you could split it, and it's just going to take you a lot of steps, a lot of work. So you could do this, make this into two right angle triangles, and then find this height, let's say we call it height, and then relate this side to this side, and then find your A side, right? So it would be a lot more steps. You can do it with trig, but again, the purpose of this is to eliminate some of that extra work you had to do with trigonometry. So that's where the cosine law comes in handy. So even though it seems like it's a quite complicated equation here, once you plug in all the numbers, you just end up with a bunch of numbers you can just do on the calculator, really. So you will end up with just one unknown. It is more difficult to find the angle, let's say if you were missing the angle. So that's the case where you're missing one side. Now in the example 2, now you're missing the angle in the triangle. So if you look here, again, first instinct should be always to think if you can use sine law. So for the sine law, you need to have at least one angle, right? Otherwise, you can't find the missing angle anywhere else. In this case, you have 0 angles, and you have to find the angle B. So again, I picked ABC here. So we have to use cosine law. Now, again, the triangle that is labeled here is already labeled as A, B, and C, so you have to pick the right equation again. So missing angle B, I'm going to find the expression which has angle B in it. So in this case, I'm not looking for the side B, I'm looking for the angle B. So the only one that has angle B in it is this one, right? So cos B. So I'm going to take this formula here, the second one, I'm going to write it out, and then I'm going to use it in my calculation for the angle. So let's write it out first, so we have it in front of us. So this is the expression we're going to use. So it's b squared equal to a squared plus c squared minus 2 times a times c times cosine of angle B. So normally this appears in square brackets like that. So we're looking for the angle B. We're not looking for the side B. So let's label our sides to complete this. So this is our lowercase b. This is our opposite. So this is our A, and this is C. All right. So we know all the sides. So we know all of these guys, right? We know this, we know this, we know that, we know this, we know this. The angle B is the only unknown. So we need to take this whole expression and solve it for the angle B. So, which means we need to subtract the a squared and the c squared first. So let's manipulate the equation first. So the first step is to subtract a squared and c squared. So we get this b squared minus a squared minus c squared equal to, in this case, this stays negative because we have a negative here. So negative 2a times c cos of b. Right? So I moved these two to the left so they became negative. The next step is to get the cos b by itself, which means we're going to take this expression on the right side and divide it by negative 2ac. So you're going to divide by negative 2ac. And we have to remember to do the same thing on the other side because this is an equation. So I'm going to divide this by negative 2ac. What this allows me to do is then get rid of the 2ac on the right side, and I'm left with just the cosine b on the right side by itself. So here's what we have right now. We have cos b equal to b squared minus a squared minus c squared over negative 2ac. Now this is an equation that solves for cos b. And actually, you could try to memorize this if you want. That's totally fine. I mean, I don't recommend it because you should be able to derive this using algebra. So normally, you don't see the equation for the angles, but you could write them out for all three of them, for A, B, and C, and just have them on the side on the formula sheet, let's say. So in this case, what we can also do, we can take this negative from down here, right? We can take this negative and bring it to the top, which means the signs on the top will change. So positive b will become negative b squared, negative a squared becomes positive a squared, negative c squared becomes positive. So this is just an extra step, which is really not necessary, but will make your expression look a little nicer because you'll get rid of some of the negatives. So what I mean by this, you're going to end up with positive a squared, positive c squared minus b squared over positive 2ac. So this is what you want to see as pretty much second last step in order to find the angle B. Now this is still cosine, so the very final step to find the angle B is going to be taking the inverse of cosine. So the angle B as the final step, so B itself is going to equal cos inverse of all of this stuff. So a squared plus c squared minus b squared over 2ac. Okay, so that's the actual expression. I should probably box this one, not that one. This is what you really want to see as your final step if you're looking for the missing angle. So finding a missing angle using cosine law can be a little challenging because there's quite a few steps here, as you can see. But again, there's no other way to find this. So we only limit it to this approach. But once you have your expression for the angle B, you can replace it with A, right? And then switch the A with B and C here in this equation here. So you can have all three expressions for all three angles in your notes whenever you do questions dealing with cosine law. So the final step, of course, is to actually find the numeric answer for an angle B. So what we're going to do here is, again, now plug in the numbers. So we're going to do the angle B, let me write it here, equals to the cos inverse, cos raised to -1. A is 10 feet, so we're going to have 10 squared plus c squared, which is, no, sorry, A is not 10, that's C. A is 19.5. Plus c squared, which is 10, and minus b squared. So b is 20, so minus 20 squared over 2 times a, which is 19.5, times c, which is 10. All right, so do the numerator first in the calculator. So you do 19.5 squared plus 10 squared, which is 100, minus 20 squared, you're going to get 80.25. Again, you can break it into parts if you want. You can break it up so you don't have everything on the calculator in case you make a mistake somewhere along the way. But again, I recommend that you learn how to use your calculator so you don't have to use steps separately. And then do the denominator, 2 times 10 is 20 times 19.5. All right, so we get this step. And of course, now we need to divide. So 80.25 divided by 390 is going to be 0.205 and so on. So from this step, I'm going to take the inverse of cosine. So I'm going to use shift on my calculator, press cosine button, and get the actual angle. So 78.125, and just keeps going. So this is the angle B. So this is in degrees. Now if you round this to the nearest degree, we end up with 78 degrees. So in this case, angle B is 78. Now once you know the angle B, that this guy is 78 degrees, what you can do, let's say if you ask to find every other side or every other angle, you can use sine law to find angle C or angle A, and that'll be quicker than using cosine law again. Okay, so it is a bit confusing at first. The best thing to do is follow the step one by one. Okay, don't try to skip any steps whenever you do these questions. Go over the examples in the textbook. Pause the video as many times as you need until you understand every step of algebra that I did here before you attempt any of the practice questions. Now I also copied the summary section from the textbook, the part that you need to know for this section. So again, you can use cosine law to solve problem, that can be modeled by an acute triangle. So again, there's no 90-degree angles. When you know either two sides and the contained angle, so contained angle means one of the inner angles, or you know all three sides and no angles given. So that's the case when you have to use cosine law. You can use sine law in that case. Okay. So when using the cosine law to determine the angle, you can substitute the known value first and solve for the unknown angle. I did not do this way. Or you can rearrange the formula and solve for the cosine of the unknown angle and then substitute the value. So that's what I did in my example 2. I rearranged the formula first, I solved for the unknown, and then I plugged in all the numbers. So it's up to you how you want to do it. The amount of work is still going to be the same. Sometimes students find it maybe a little easier if you just plug in the numbers first, because then you have to deal with all these variables. You can just plug in the numbers into the very first equation here, and basically you're going to end up with all these numbers. You can simplify it, and then you can find the angle B that way. The only issue with that approach is that you might end up with some rounding errors, because a lot of these numbers might end up being decimals or irrational numbers which have infinite number of decimal places, so you'll have to round it. And whenever you round, you end up with some errors in the end. So I recommend you actually use the approach that I did here, basically rearranging the formula, but you can still solve the question if you don't want to do that. Okay, you can still just plug in the numbers right here and then solve for the angle B. It's up to you how you want to do it. But just be warned that you might end up with some rounding errors. So some of the practice questions for 3.3 are, again, make sure you read question pages 130 to 136 and do number 2, 5, 7, and 13.